All right, let's talk about something you probably have in your fridge right now: butter. It seems so simple, right? Just a golden block of deliciousness. But it's actually a mind blowing marvel of food science, physics, and chemistry. Let's get into it. So, it really all boils down to this one question: how in the world do you take a flowing liquid, like cream, and just by shaking it around, turn it into a firm, spreadable solid? It honestly feels like some kind of magic trick, but it's pure science, and we're going to pull back the curtain.
Okay, to really get the transformation, we first need to understand our starting point and our final destination. What exactly is butter and what are we doing to cream to make it happen? So here's the secret. Butter is what's called a water and oil emulsion. Just picture tiny little droplets of water that are trapped inside a big, continuous network of fat. Now, cream is the total opposite. It's an oil and water emulsion, where little globules of fat are just floating around in water. The entire process of making butter is about flipping that structure completely inside out.
And if you look at what's actually in a stick of butter, it's overwhelmingly fat. By law, it has to be at least 80% milk fat. That's the main event. The rest is mostly water, about 16%, that's trapped inside that fat network, along with a little bit of milk solids and salt for that classic buttery flavor.
So here's our basic roadmap. It's a 4-step journey. First, you prepare the cream. Second, the all-important churning step. Third, you work the butter to get the texture just right. And finally, you package it up. Let's dive right into that critical step, the churn. This is where the real magic happens. Churning isn't just some gentle mixing. It's a controlled, kind of violent process that's specifically designed to completely restructure the cream on a microscopic level. And the scientific term for this incredible flip is phase inversion. It sounds complex, but it's exactly what we just talked about. It's that dramatic moment where we physically force the fat to become the container and the water becomes the thing that's contained. So how does that actually happen? Well, here's our starting point. Inside the cream, you've got these millions of tiny little spheres of fat, and each one is wrapped in a protective layer, a membrane. This membrane is the key. It acts like a little jacket, keeping all the fat globules separate and happily floating in the watery part of the cream. Then we start churning. This agitation whips a ton of air into the cream, creating a foam. And the air bubbles in that foam, they're the secret weapon. They act like millions of tiny wrecking balls, constantly smashing into those fat globules over and over and over. After enough of a beating from those air bubbles, the fragile little membranes just give up. They rupture. You can think of it like popping millions of tiny greasy balloons all at once. And this exposes the raw, sticky milk fat that was hiding inside. And that fat hates water. It's hydrophobic. So now, with their protective jackets totally gone, there's nothing stopping these sticky fat globules from clinging to each other. Because they hate water so much, they all start to clump together, forming bigger and bigger clusters and squeezing the water out from between them. And just like that, the phase inversion is complete. We've done it. We now have a solid mass of interconnected fat. These are the butter grains. And we have a separate liquid, which is the original water from the cream. And that liquid is what we call traditional buttermilk. But hold on, we're not quite done. Those raw butter grains, they're not the smooth, delicious butter we're used to. The next steps are all about refining those grains into the final product. From here on out, the whole process is about meeting very specific standards. To be sold as table butter, for instance, the final product absolutely must have at least 80% fat and no more than 16% moisture. It's a really precise science. So to meet those standards, the butter is worked, which is really just a fancy way of saying it's kneaded. This does two critical things. It squeezes out any leftover buttermilk to get the moisture content right, and it also presses all the fat crystals together to create that dense, waxy, and perfectly uniform texture we expect from a block of butter. So, why is some butter beautifully soft and easy to spread right out of the fridge, while other butter is basically a brick that just destroys your toast? Well, the answer lies deep in its chemistry, down at the very structure of its fat crystals. Believe it or not, a huge factor is simply what the cow was eating. Cows that graze on fresh green pastures in the summer produce milk with softer fats.
But in the winter, when their diet switches to drier hay and grain, the fats they produce are harder and more saturated. And that gives you harder butter. It's that simple.
And this is where it gets really fascinating. It's not just the type of fat, it's also about how it crystallizes when it cools. Fat has this amazing ability called polymorphism, meaning it can form crystals in different shapes. For that perfect smooth butter texture, makers want to create lots of tiny, stable beta prime crystals. If they cool it wrong, they'll get large, gritty crystals, and the butter will be brittle and crumbly instead of smooth.
Now that we've got a handle on all the modern science, let's just take a quick step back. Because making butter is a truly ancient art, one that we've only very recently perfected with industrial technology.
I mean, just look at this timeline. Humans have been making butter for at least 11,000 years. That's incredible. But the major inventions that allowed us to mass produce it, the cream separator and the continuous butter maker, they're shockingly recent. We're talking less than 150 years ago.
And this comparison just shows that technological leap perfectly. On one side, you have a simple, traditional wooden hand churn. And on the other, a modern industrial machine, a beast that can churn, work, and salt butter in one continuous flow, pumping out thousands of pounds an hour. It's the same core scientific principle, just scaled up to an absolutely epic level.
And finally, here's a little food for thought. The word butter has ancient roots, going all the way back to Latin and Greek. But get this, in ancient Sanskrit literature, one of the words for butter was bhutari, which means the enemy of evil spirits. It just shows you how incredibly valued this energy-rich food has been throughout history, seen as something protective and pure. So the next time you go to spread some butter on your toast, maybe just take a second to appreciate it. It's not just food, it's the end result of a physical phase inversion, of controlled fat crystallization, and literally thousands of years of human ingenuity. It's science you can eat.